We are now on video number 9 of this series. In the last video, we talked about the contact closure interface, and as promised, today we're going to talk about sACN and sACN priorities. sACN stands for Streaming Architecture for Control Networks. We just call it sACN. Sometimes people call it ANSI E1.31. And at Pathway Connectivity, we have secured that protocol so that you don't have bad actors trying to control your lights, and we call that SSACN, or Secure Streaming ACN. They're all the same. They all move along the Ethernet network. They can go through Ethernet switches. They can come in from multiple locations and go out to any number of path ports. And typically you transmit an entire universe of 512 data slots, and we see that in the last mile on the recommended connector, the 5-pin XLR, and that goes from light to light to light multi-drop. The advantage of having a protocol like sACN is you can have multiple transmitters, and then the last mile device, the path port gateways, or the 2 ports on the snapshot controller, can then arbitrate who actually creates the DMX512 that goes to the lights. So that becomes really interesting when you have multiple controllers. And once you have multiple controllers, you need to have rules. You either need to say the architectural controller sits in the background and the theatrical controller is more important, so the architectural controller should fall back and let the theatrical controller take complete control of the rig. Or you can say they're equally important, and then we should take each slot of the 512 and merge them together. And the way we do that is we do highest takes precedence. So on each slot, which level is highest, that is what goes down the 5-pin XLR. So, or you could reverse the priorities. So in the sACN standard, and adopted also by SSACN, are 200 priority levels. Now, generally, out of the box, most devices go out with a priority of 100. If you want to make it more important, you just bump it up to 101. If you want to make your source yield to other sources, you drop it down to 99. Now, when I was setting up for this, I was thinking, I was even getting confused of what is what. So I'm just going to have 2 sources, 2 colors on different lights, so we can say who's winning, who's falling back, or are we working together? And what I've done is I've used my tile here. And remember, we had the patch where we called fixture 1, 2, 3, 4 all the way up to 16. What I've done is I have taken a lighting console. I'm going to transmit and plug into my demo case, which goes into port B. Currently it's configured as an input because we can see it's flashing amber. As soon as I plug it in, it's going to go active, solid, and it's going to start transmitting to my tile. Now what I've done is I've taken the outer ring and made them blue. Now, to that vein, I don't want to forget that this is blue. So look, I made a little piece of paper, and I'm going to plug this in here. So whenever you see something plugged in here, we should see the blue lights on the outside. So I'll just unplug that, and they will fade away in a second. Now, the second controller is going to be our architectural controller itself. And for that, let's have a look at Pathscape here. On the outputs, I've taken output number 6 here, and I called it the red center. And I've patched that in sensor view to pole 2 of my nPWD M here. And it's a zone, and when I bring it up, you will see it brings up the 4 lights that I didn't bring up before. Now, the way I did that is I went into the advanced zone editor and I looked at my patch map and I said, okay, yeah, this light starts at DMX slot 16. There's 2 lights and there's an increment of 3. So that gives me the reds. And then this guy here starts on 28. There are 2 lights with an increment of 3, and that gives me 2 more lights. It's pretty simple. All I really want you to remember is that this controller here is red. So when I activate it or deactivate it, we will see the red lights, and when I take my DMX console and I plug it into the XLR jack, we see the blue lights. So let's look at the base device itself. So we have the network DMX transmit protocol, and it's sending out pathway sACN, and it's sending out at a priority of 100. It's sending out red, in this case, at a priority of 100. Okay, just remember that. Now, port B, which is marked in blue here, it is transmitting with an sACN priority of 100. So if I have them both on at the same time, what's happening is we are merging the effect of them both, right? So if I take the DMX away, the lights that were controlled by it go away. If I take away the zone, it goes out. If I bring in the blues, they go in priority 100. Reds come on at a priority 100. So we know the blue lights are coming in our DMX port. So if I up its priority one above 100 and I send those transactions off, what do you think is going to happen? Well, since our lighting console is not talking to the lights in the middle, but it has a higher priority, it is going to, we call stomp on top of those levels with its higher priority 0 level, which is black. And that's why we have a hole in the middle. Now, the opposite can be true too. Let's go back to 100 just so that we see the merge. So now we are getting red from here and blue from there. Now, if I make the blue, the DMX connector, a lower priority, it is not addressing the outer ring, and it has a higher priority. Remember, it's at 100, a higher priority, but a lower intensity. The intensity is black, and that's why you don't see it. So we could do this from the other side. Let's just move the DMX connector back to 100. And if we go to the snapshot controller itself, and we change its priority, remember it's at 100 now. If we lower its priority to 99, then the DMX console is driving the whole rig. And the neat thing about that is if I unplug the DMX console, it crossfades to what the architectural controller would like the rig to look like. Theatrical guy comes in, plugs in, he takes complete control. Theatrical guy leaves, it comes back to the architectural control, which can then turn things off at the end of the day. Let me just put this back to 100. And what's important to remember is that we don't actually, in a modern day and age, need to use the 5-pin connector for DMX in at all. A lot of controllers output sACN or sSACN directly on the Ethernet. Such as myself right here, I've got Cognito PC running here, and if I have the blue look up here, but I've disabled my outputs. Let me go into my setup here and show you that my streaming ACN priority is 100. So if I enable my outputs, there we go. It is doing the same sort of thing, and since it's at 100, it's merging with the architectural controller. Now on the fly, this is what's kind of fun, I could go and I could up my priority to 101, and now I have the entire rig. And if I wanted to, I could go in here and I could grab these lights and I could bring their intensity up and put them into any color I want. You know, like this. And then at the end of the show, I can just disable my outputs and it will crossfade to what the architectural controller is up to. And if I enable my outputs, I take full control again. And let me release these out. And if I wanted to be equally important as the architectural controller, I could just take my sACN priority and match it to 100. And then I get the merge of both of the controllers. So there's lots to think about with sACN priorities. There's all kinds of ways to do it, and the path ports and the ports on the snapshot controller take it much further than that. You don't have to do entire universes. You can do custom patches where you take a little bit of this guy and a little bit of that guy and you merge them together, and you give these slots a higher priority than those. And there are other videos and lots of information in the Pathscape manual on how to build custom patches. So whenever you're in a tricky situation and you need a little bit of control from here and a little bit of control from there, have a look at custom patches on path ports. In the next video, we're going to talk about RDM, or Remote Device Management, and that's where we get feedback from the fixtures in the field and we can see that information in Pathscape. So please join me for video number 10 in this series.